Alright, so the next lesson's on standard deviation. And standard deviation is the spread from the mean. Actually, let's talk about that right now. So it's a different concept, and it's one of those concepts that it's actually you want a small standard deviation. You don't want a large standard deviation. So here's a problem where Nanaimo and Toronto have different daily temperatures. And so the average Nanaimo is 9.5, and Toronto's 9.5. And median is 9, and Toronto is 9. The temperature is in Toronto are more spread out. So let's just outline so maybe we can understand them a little better. So should be a legend here. Which ones, if you can kind of see here, Nanaimo was 3, so it's the black ones. Okay, so I'm just going to kind of outline it just so I can see, okay, who's who. Okay, so that was Nanaimo. And then the other one is Toronto. Okay. So green is Toronto. So just so I can kind of see the difference between the two. So the temperature in Toronto are more spread out or dispersed. Okay, so the data is there's the average. Where's that average line? Well, they told us Toronto's average is around 9.5. It's mean. So around here is Toronto's average. And they both have the exact same average, actually. Nanaimo has the exact same average as Toronto. But notice how Toronto's, the data is way more spread out from that average. We have really high highs and really low lows. And so it's very dispersed, whereas Nanaimo is has that central tendency. So standard deviation is central tendency. So Nanaimo, it has a tendency to stay closer to that average, to that middle, whereas Toronto is very dispersed because it's very far away from the mean. So measure of dispersion is basically, let's highlight that instead of cross it out. Measure of dispersion together with a measure of central tendency to describe data. So we can not only find average, but also talk about, hey, how close is that our data to the average? Because although they have the same averages, they're totally different pieces of data, right? And you can see that. So mean is not everything. We also want to talk about how spread out is our data. So one way we can talk about dispersion is through something called range. So we actually take the highest and the lowest, and we find the difference between the highest and the lowest. So looking at, so we should talk about this. So difference between highest and lowest. Highest and lowest data. So here, what was the lowest data we had for Nanaimo? Nanaimo, we had the smallest was 3, and the highest was 18. So the range of data is 15, 18 minus 3. Okay, so how about here? The lowest for Toronto was -4, and the highest was 23. And so the distance is 27 between the two. 23 minus -4 is 27. And so range is one way you can talk about that dispersion. Another way, or even better way, is called standard deviation. And that's the measure of central tendency. So standard deviation is central tendency. So what's the spread? How far away are things spread from the mean? Spread from the mean. Are they close to the mean? So if all your data is very similar to your mean average, then it's going to be a low standard deviation. And in statistics, we actually want lower standard deviations because we don't want data where we have the two extremes, and yes, it averages in the middle, but we have these two huge extremes. Our data is not very close to our average. So here's a definition. Standard deviation is a measure that describes the variation or spread between the data and the mean data. A low standard deviation, that means that most of the data values are close to the mean. So this is usually really good. It means that things are consistent. We want consistent. High standard deviations means our values are not very consistent because they're very spread out. They're very scattered. It's often used to compare two sets of data. So the standard deviation of population is the sigma, and that's what we're going to use. We're not going to use the S. Now, all this stuff that's going on here is how we calculate it numerically. You do not need to know that. So we're going to skip it. All you need to know is how to do it in your calculator. And remember, we pointed that out in the previous lesson. So let's use, we're going to skip number 1. Go straight to the graphing calculator. And we're actually going to use the data from 1 to find the standard deviation and the mean. So let's use above's data, and let's review how to do that. So with your calculator, I better get mine out. Open up. There we go. So with your calculator, you're going to enter, again, we go stat and edit. And we're going to put in our data. So in L1, 170, 182, these are heights of basketball players, 193, 193, and 212. Okay, so from there we're going to go stat again because that's our home base, and we want to go over 1 to calculate one variable statistics, so number 1, and then just enter. We don't have to put L1 because there's only one list. So from that, remember from last day, we can get our mean, which is the x with the bar, which is 190. You can see on our calculator right there. And our standard deviation is this one right here. It's kind of circling. And that is the little sigma symbol. That little sigma symbol, it's a Greek letter. It's 13.9. 13.9. So that's the spread, how far away, the average of how far away our data is from the center. Okay, so let's try another question. Oh, I think I was supposed to fill in that data on the other side. So using our graphing calculator, we had our mean of 190 and our standard deviation of 13.9. Now each player grows by 5 centimeters in the next year. Ooh, this is good. Without doing any statistical calculations, explain how to determine the change in the mean height. If everyone grows by 5 centimeters, then our average is also still going to be 5 centimeters. So our new average would be 195. Okay, so it would be increased by 5 since all players increase by 5. I'm going to write that out. It increased by 5 centimeters since all players, let's try this again, since all players increased by 5. Now let's look at the next one. Standard deviation of the heights. If they all increase by 5, does that change their spread from the average? And the answer is no. So the standard deviation would stay the same. Because they're all increasing by 5, so they're all distance from the mean is still the same. So it should remain unchanged since all players grew the same height, meaning the data is not more or less spread out. Meaning the data is not more or less spread out. Okay. The last thing that needs to be covered is how do we find standard deviation with a frequency table. Remember, your first one is L1, the second's L2. We actually have done this before. We go stat, edit, go clear, go back down, and so enter in our actual values, so 0, 1, 2, 3, 4, and the frequency goes on L2. So we had 5 zeros, 10 ones, 4 twos, 3 threes, and 1 4. And let's get some context to the problem here. It's hits per game for a baseball player. So let's find the mean and standard deviation. So stats are home base. We go over to calculate. Number 1, now remember if we have two things, we have to go second number 1 for L1, comma, second number 2 for L2, and then enter. So x bar is our mean, so 1.3 is our mean, and sigma is our standard deviation. So we go down, and it's right there, 1.1 is our standard deviation. So notice how our mean and standard deviation are very similar. It's a pretty big standard deviation. And so our data is a little bit spread out. And so that's 1.1 hits per game, and 1.3 hits per game is our mean. All right, last question here. Without doing any statistical calculation, explain which quiz has the greater mean. So mean is average, right? So it's hard to see these right now. I'm just going to outline them. So whereabouts would the average be for this first one, and whereabouts would this average be for the second guy? Well, average is about at 3 for the first. It's about 5 for the second. And so quiz B, or stats quiz, has the greater mean. So we're explaining, so we need to use words. And so why would that be? Because the data values occupy a higher numbers. Since the data occupies higher numbers. So whenever you see the word explain, we need sentences. This word since, higher numbers. How about standard deviation? Remember, standard deviation is your spread from the mean, so how much your data is spread out. So in number 1, most of your data is very close to your mean. It's very high around the average. Whereas 5, it's more spread out. Sorry, not quiz statistics. It's more spread out. And so a greater standard deviation would be statistics because it's more, so since statistics, since the data is more spread out. So it wants us to use our calculators to confirm this. So we're going to turn this into a frequency table. So for the first guy, we have to go to Stat, Edit, clear both of those. So clear, go back down, up, clear, back down. So the first one, we had 0 zeros. So our numbers are 1, 2, 3, 4, 5. So let's count how many we have of each. So I have 1, 1. I have 3 2s. I have 6 3s. We have 4 4s and 1 5. Okay? And so let's calculate. Stat, calc, 1. Remember, we have to go L1, comma L2. It's frequency. And we get the following. Our mean for our quadratics, our mean is the nearest tenth, 3.1. And our standard deviation is the bottom one, well, to the nearest tenth is 1.0 if we round that. Okay, so let's do the same thing now for our stats. So I go stat, edit. I'm going to clear our two tables, our two lists. Okay, so I see the numbers 3, 4, 5, 6, 7. And we have how many of each? We always have 3. 3, 3, 3, 3, 3. Stat, calc, number 1, go L1, comma L2. And so our mean is 5, our standard deviation 1.4. So who had the higher mean? Higher mean, again, was stats. And higher standard deviation was also stats. And there you go, and that's the end of this lesson.